Based on what you already know from the kramers-kronig dispersion relationships, can you show that if you have a material which is non-dispersive, that then automatically that material should be vacuum? So pause the video to figure out that this is indeed the case. We already know from a previous exercise that if you have a situation without dispersion, that in that particular case we are dealing with a lossless material. So that's something we already know, but in this case we take this one step further. We should also show that this is not just any lossless material, this actually has to be vacuum. So this is what we need to figure out. Now in the kramers-kronig relationships, we're going to work with the function f of z is delta n, which is the refractive index at a certain frequency omega minus the refractive index at infinite frequencies, which is 1. So we know that the material should be lossless. So this means that the imaginary part of n should be equal to 0. And that also means that the imaginary part of delta n should be equal to 0, because 1 doesn't have an imaginary part. So knowing that, we also know that we can use the kramers-kronig relationships to calculate the real part of delta n as some sort of scary looking integral which involves the imaginary part of delta n. So it's not really important what the other factors here are, because since the imaginary part of delta n is equal to 0, this whole thing vanishes here. So this also means that the real part of delta n is equal to 0. Now, if the real part of delta n is equal to 0, that means that the real part of n itself is 1. Again, because delta n is n minus 1. So if we bring everything together, we know what the real part is, we know what the imaginary part is. The only conclusion there is that the refractive index itself should be 1. And that means that the material we're dealing with actually is vacuum. So vacuum is the only possible non-dispersive material.